Good afternoon. My name is Vaibhav Nivargi. I'm one of the founders and CTO of Moveworks. I'm here today to talk to you about how Moveworks uses fine-tuned large language models for providing AI-powered employee support to global enterprises. I have 20 minutes, or probably less than that, and a bunch of slides. I'm going to dive right in. The problem that we focus on at Moveworks should be familiar to most folks here. The experience that employees have in your workplaces when they have a problem is full of friction. Now, this could be problems with software they are using, with hardware, with facilities, benefits, payroll, PTO, approvals, so on and so forth. They have many internal systems and channels for help that they can go to. Each of them have different SLAs. Some maybe have no SLAs. They can file a ticket, they can try to self-service, they can call a number, they can fill out a form, and the systems underlying these are vast in number and growing. So it's no surprise that on an average, an employee's service request, whether it's IT or HR or finance or facilities, takes hours and days inside some of the most advanced organizations all over the world. So that's the problem we decided to focus on about 7 years ago. When we looked deeply into this, we realized that this was a problem that dealt with understanding language. Employees express their problems in highly symptomatic language. They use jargon, company-specific vernacular, abbreviations, acronyms, typos, and being able to understand what they are saying and act on these systems is non-trivial. Fortunately, that's an area where large language models really shine. So this is what the picture looks like with Moveworks in the mix, where Moveworks offers a conversational AI interface that disintermediates access to the underlying systems. It manifests in tools like Slack, Microsoft Teams, Google Chat, web, voice, and is powered by over 200 proprietary machine learning models, large language models, as well as conventional models that are fine-tuned on enterprise data. There's over a petabyte of data that powers these models, and they are grounded in enterprise context. Think of it as business rules, processes, entities, actions, access control rules, so on and so forth. And Moveworks can act on the underlying systems, ITSM systems, identity systems, HRIS systems, and bring down the resolution time to seconds from hours. In a nutshell, Moveworks is an enterprise-wide co-pilot that can connect your people to systems at the speed of conversation. I don't know how readable this is, but you can see sort of an example of what a user interaction could look like, where a user named Madison comes in saying they need access to PowerPoint. Moveworks understands what they're looking for, who they are, what is the right way to give them access, and goes through with provisioning PowerPoint and filing a ticket, so IT teams can know where all the licenses disappeared. We think of ourselves as a co-pilot. That's another perspective to think of Moveworks, the definition of which is a conversational interface for automating tasks, finding knowledge and information that leverages large language models. And this term and this concept is proliferating now, whether it's in our personal lives through things like Spotify and Khan Academy and others, as well as in our work lives, where every couple of days, somebody's announcing a new co-pilot, whether it's Tableau or Salesforce or Box or GitHub or Microsoft. So it does seem like it's a matter of time before every single tool that we are using is going to have its very own co-pilot. And all the product leaders, engineering leaders here in the audience today, as David mentioned, must be thinking about this. Some might be early in the process, some might be much further ahead. So what I want to offer you is our experience of building a product like this, building a platform like this over the last 6.5 years. Starting with what exactly do we do and how we do it. So while OpenAI would like us to believe that there is one single model that's going to rule them all, certainly today that is not true. So what we end up doing at Moveworks is we harness the best language models out there today for their specific capabilities. And what you're seeing up here is a chronology, a timeline, if you will, of the different instances where large language models were introduced in our product stack. These are all fine-tuned models. So we take customer data, enterprise data, and take these pre-trained models and fine-tune them, improve their performance, manage their latency, and deploy them in production. Some of these are much smaller, and they barely even qualify as a large language model today. Something like BERT or Roberta with a few 100 million parameters probably doesn't even compare to the trillion parameter beasts that we have today. But they are great at classification tasks. They are great at language translation. And finally, GPT-3 and GPT-4 class models are excellent at more advanced tasks like reasoning or even synthetic data generation. That's where we use them. Model selection is non-trivial. If you go to Hugging Face and look at the language models repo they have, there's something like 18,000 models as of 2 weeks ago. Today, the number is probably closer to 20,000. There's a lot of options, a lot of choices out there. So how do you go about picking the language model or even a video model or an image model for your use case? So this should give you a rough framework for how to think about this. As you understand your use case, you have to think about the modality of data. If you're dealing with text, you have some options. With images, with video, with audio, options reduce. If you have certain amounts of data, there are theoretical bounds on how big models you can train. So if your data set is limited, as was the case with us in the early days, you could only train models up to a certain parameter size. Depending on your use case, you may or may not need advanced things like few-shot learning or zero-shot learning. For example, if you're doing classification tasks, sentiment analysis, things like that, you probably don't need the kind of functionality that ChatGPT has, where it is doing in-context learning with a few examples and prompting. If you're sensitive to cost, potentially using an API is going to be expensive. Easy to get started, but the costs ramp up very quickly. That's where amortizing the cost by hosting your own models can be beneficial. And finally, latency is an important concern. That's why you see Anthropic and OpenAI do character-by-character, token-by-token rendering. Otherwise, you would be waiting for minutes for getting entire payloads and messages out of these large models. So as you go through and analyze your particular use case, options narrow, and certain language models can stand out for your particular choices. Another important consideration is licensing. I think folks here would have seen that when models like Llama were announced by Meta, they weren't allowed to be used in commercial settings. That's another factor to keep in mind. Now, how we use language models in a stack is something that is best explained by an example. Now, one approach that there are examples out there in the open source community where one single language model can handle end-to-end task delegation. Now, that has complexity. That has challenges with control. That has problems with hallucination, and as well as problems with improvement of functionality. Whereas the approach we take at Moveworks is to break down each individual task into the specific subcomponents that can be individually optimized, resulting in the overall process getting better. Here you see an example of a user, Alex, coming to Moveworks saying, how many MacBook Pros do we have in our inventory? Instead of having one model that does the end-to-end exercise, we break down the task. We say, let's try and identify what are the typos in the utterance. Easier said than done. Something as simple as spelling mistakes can be company-specific, because one company's spelling mistake could be another company's specific entity. So that requires a company-specific, organization-specific model. Then come things like domain detection, entity detection, intent classification, which are relatively simple classification tasks, can be very easily handled by the Roberta scale of models, which can be fine-tuned. As you go further down, you get into GPT class of models that can extract relevant slots and parameters from related utterances, which can be passed to downstream API calls. And this is something that is more deterministic compared to the earlier part, which is highly probabilistic. But that's the kind of accuracy you expect, and the answer that can be then sent back to the user. I've mentioned fine-tuning a few times. There's enough evidence and research and understanding now that fine-tuning can exceed the performance compared to prompt engineering. And this chart is from a recent paper from Google that shows that even as model sizes keep scaling, fine-tuning on domain-specific data can lead to significant advantages compared to prompt engineering and prompt tuning. And here the benchmark is Superglue, which is an advanced benchmark that's used for these large language models. So that has been our experience as well. Over the last 6 years at Moveworks, we have accumulated something like 500 million IT tickets, knowledge articles, workflows, conversations, happy paths as well as unhappy paths. And this has helped us train and fine-tune our proprietary large language models that can be used to improve the accuracy of our product. Why is this relevant? Let's look at a slightly more advanced example. In this case, a user comes in saying, can I get my direct report, Zhang, MSFT Teams license? As you think through what is the underlying process that a human would go through, it's very similar what our bots have to understand as well. In this case, we have to figure out who Zhang is, what does MSFT Teams mean, how do you give a license in this particular org? Maybe the rules are different based on the user's location, if somebody's in Europe versus North America. There is a question that needs to be asked, because Zhang already has a Teams license, but needs to upgrade to an elevated role. And that's something that the bot can do on the fly. And on the left here is the kind of tasks that are chained together that have to complete with a very high level of accuracy. If any of this step falters, the user experience suffers, and the users won't come back, which leads to degraded performance. Now, for each of these steps, we have evaluation data sets. As you folks go through implementing copilots and training your own, fine-tuning your own models, evaluation becomes an important concern. Now, this is something that most papers and model providers publish, but there is a caveat. Most of these large models have hundreds of billions of parameters. And there is some open debate as to whether these models are good at memorizing data, or are they actually solving the problems that you are being asked to solve. As an example, for GPT-4, there was some discussion around how the performance on programming languages was really great up to 2021. But toward 2022 and beyond, the performance suffered dramatically. Now, in this case, for each one of these subtasks, we have production-level data that's hidden, that's secret from these models. And we can compare the performance of the MoveLM 7 billion and the 175 billion fine-tuned Moveworks-specific models to GPT 3.5 and GPT 4. And what you're seeing here for the first two columns is the relative performance improvement where these models, in a zero-shot setting with no information, beat GPT 3.5 with a few-shot setting in every single benchmark. And they also beat GPT 4 in over 90% of them. So this goes to show that fine-tuning can have tremendous benefits, especially if you are in domains where there is rich domain-specific data. You have the infrastructure to fine-tune these models. This is something that's highly advisable. That's not enough, though. Having a model that understands data is a part of the story. For a copilot like Moveworks, which can take action on IT systems, HR systems, for teams that span the globe, it's important to understand how to make a decision. And conventional conversational toolkits and chatbots model this as a dialogue flow, which is very rigid and very structured. In that case, if anything in the environment changes, you have to make the changes in multiple places, becoming very brittle. So instead of that, we model this as a machine learning problem, as a ranking system, where we can look at a user's utterance, how do I get access to NetSuite, and look at all the relevant metadata. Who is this user? Where are they coming from? What is NetSuite? What is the process to give access to NetSuite? And maybe there is more than one right answer. You could directly provision the software. You could give them a knowledge article. You could have them fill out a form. And depending on the context, depending on the decision-making system in the model, you can rank some systems above others. The beauty of this is this becomes dynamic. If a new mode gets introduced in the system, it gets ranked appropriately without having to make a change in code, without having to make a hardwired change in a dialog tree. The other elegant approach here is it couples with the downstream action engine, which we saw earlier. The probabilistic reasoner can engage with users, can ask follow-up questions, can collect all the relevant slots for all its information, and then trigger the downstream system. This is something that we have seen recently through open source systems like LangChain, which try to drive action through using large language models. Similar approach, where the reasoner can drive action by collecting information, and these systems can then evolve independently. As the reasoner gets smarter, it can trigger more sophisticated actions. As more actions become available, the reasoner's capability set increases. Now, this drives both of these to improve at the same time, leading to more engagement, more resolution, and more adoption. Net result is that the Moveworks system can natively talk to over 100 enterprise systems out of the box. When we deploy to customers, they can start making changes in all of these systems. We can start resolving tickets in a matter of seconds. The bedrock for all of this, though, is a strong foundation of security and privacy. Unsurprisingly, given that we train on customer data and make changes in customer systems, it's extremely crucial for practices around data security, around governance, around privacy. Infrastructure hardening is something that's built into the platform. And you can see on the left here, I didn't change the slide. And you can see here that there are investments we have continued to make on compliance initiatives, even things like FedRAMP for civilian agencies and defense contractors. The net impact is that Moveworks customers can expect anywhere from 60 to 75% issue resolution when deployed within their environments. For customers like Stitch Fix, they have seen almost a 550x speed up in approval time in their environments. Palo Alto Networks has seen almost 350,000 hours of employee productivity saved in less than a year. And Nutanix has seen resolution time go down from 2 days down to 7 seconds on an average. All right, that was fast, but that's what we work on. I'm sure all of us here are fans, if not students, of Conway's Law. So I want to make sure I at least touch on what are the teams that help build some of these products at Moveworks. Not meant to be exhaustive, but I do want to touch on certain key personas and roles. Unsurprisingly, AI and machine learning teams play a big role. It was mentioned earlier, this is not something that's available in most companies if that's not where you got started. But for us, AI and machine learning is existential and core to Moveworks' success. So we have invested a lot in building these teams. And you can see a breakdown of the AI team into language understanding, search, and conversation engine, with each team making significant investments in infrastructure. Now, the one difference in the machine learning teams at Moveworks is these are comprised of machine learning engineers. Hence, they are responsible for the end-to-end lifecycle from experimentation, ideation, dataset curation, model training, all the way to deployment in production and optimization of these systems. These teams also have their eyes and ears open given the rapid rate of change that's happening in this environment. So things like paper reading and presentations and guest speakers is something that's part of the core culture. Annotation is something that's probably unique and very important to us, but may not be an important function inside most companies. But care and feed of these machine learning models, labeled data, supervised data, reinforcement learning with human feedback. These are terms that are becoming popular now, and this has been investment we have been making for over 6 years now, where we have an in-house annotation team comprised of scribers, annotators, data scientists, with an in-house application that we have built to label data. Of course, a large part of these tasks are conventional, things like data labeling, classification, and ranking with model evaluation. But in the new era of generative learning, these teams are also spending their time in things like prompt tuning and instruction generation, such that these models can then be deployed inside broader domains with zero-shot and few-shot capabilities. As you delve deeper into building copilots, investments in design will take center stage. Even though language is the most intuitive and obvious user experience, introducing that into existing products can be fraught with friction and challenge. So having design be a first-class citizen, partnering closely with our engineering and machine learning teams is something we have been investing since the early days of the company. And driving for adoption, focusing on user empathy is something that the design team at Moveworks has gotten exceptionally good at. Platform integrations, we just had a panel about platform. This is something that extends the actionability of the Moveworks system. Being able to talk to the 100+ systems in an extensible way, something that keeps in mind permissions, access control, and the rules inside specific organizations is something that is core and key to this team's success. And lastly, security. OpenAI again showed us when the GPT-4 technical report came out how red teaming and testing of their model is becoming more and more crucial. That's what this team does. It partners closely with the machine learning team, with the engineering team, and has red team, blue team, purple team, many colors, security exercises, penetration testing, compliance, and certifications as well. All right. Beyond the teams, let's take a quick look at the underlying infrastructure. What is it? What are the key pillars of enabling a product that's powered by fine-tuned machine learning models and language models come to production? 4 key pillars, starting with data. And this is something I mentioned before. Over 500 million tickets, over a petabyte of enterprise data is something that we maintain in our environment, which is labeled with our annotation team. There's over 200 machine learning models that we train, deploy, and maintain, majority of which are company and organization specific. They're private to a given customer. Now, for these, the training frequency depends based on evaluation. Some of these models may overfit, may drift, may underfit, and may get retired. There's something like 50 to 100 model updates we push every month to a quarter. At our scale, we are seeing anywhere from 5 to 10 million user interactions happen on our platform every month to every quarter. And not all of them need annotation, but a significant percentage of that goes through our annotation pipeline. To take a quick look at each one of these pillars in a little more detail. Data, of course, unsurprisingly, is very crucial to this whole thing. Considerations here for all of you would be, what kind of mix of data is needed for your use case? If your domain is adjacent to a public domain data set, maybe public domain data is good enough. Data from Stack Overflow or Reddit or domains like that. If you have private data, a mix of the two can lead to amazing results and models that do really well in production. If you don't have enough data, there's increasing research on how to do synthetic data generation, especially data that's in distribution to the data that your models care about. And that's something that GPT-3 and GPT-4 are excellent at. So this is what we do at Moveworks, where there is proprietary data as well as public data with annotation infrastructure that we own in-house to build, train, and monitor the performance of these models. Speaking of training, GPUs are probably the most scarce resource on the planet right now. Even OpenAI can't manage to get them. So for us, on our NLU infrastructure team, we have enabled a polyglot environment where we can train on our infrastructure, where we have servers of GPUs, Azure, as well as AWS. And this becomes especially important given our multi-region and tenancy requirements from certain customers. When it comes to the deep learning framework itself, we have a modified version of Torch that we use. There's many options here as well, and all of them are fairly robust and reasonable now. When it comes to the training platform itself, when we got started, tools like Mosaic and DeepSpeed didn't exist. So we had to build something and maintain something in-house. And from an algorithm perspective, I think I've covered this, fine-tuning. Parameter-efficient fine-tuning is something that is recent research, which shows how you can take language models and have very small, very cheap extensions to these models that can be handled in a privacy-sensitive manner. So that's something that we do. It's something that's probably going to become a common blueprint for training copilots going forward. And reinforcement learning with human feedback is primarily for aligning these models, for having responses that are safer and more responsible compared to the vanilla underlying large language model. Once you have the model, the last step is deployment and inference. This is where, depending on your use case, things like latency, scalability, first time to token, or the entire message response time, multiple concerns might apply. Tools here include things like quantization, distillation, where you can take larger models, and for the loss of some precision, you can downscale these models and still continue to operate. As you keep scaling up and deploying more models, things like Onyx from Microsoft, Optimum from Hugging Face, NVIDIA TensorRT are options that allow you to do runtime deployment of these models, which for maintaining high SLA for us becomes extremely crucial. Ongoing eval is extremely important, especially with data sets that you can curate and hide from your models, as I mentioned earlier. This is sort of another view into the MoveLM numbers. We do this all the time. As new models are being announced on a daily, weekly basis these days, we try to compare the performance of the best small models to the 7 billion parameter model, all the way up to the GPT class of models as well. And here again, this reinforces the benefit of fine-tuning on domain-specific data. Now, that was at the model scale. We still have a product. We still have resolution, users using it. So analytics need to be up-leveled at the product scale as well. And that's where we need to answer questions like, how many successful interactions are happening? Are users actually using the product? What unsuccessful interactions are happening, which are the gaps in the product that we need to improve? And this is our approach of doing this, which we call Employee Experience Insights, which is powered by NLU and powered by these language models, and lets our customers look at individual interactions as well as clusters of these to identify happy paths as well as unhappy paths. And for the unhappy paths where resolution didn't happen, our system can make recommendations. Missing knowledge, incorrect knowledge, missing automations, incorrect actions, all of these can be improved within the system. So you can track day over day, week over week, month over month improvements. So there you have it. Whether it's XBot at Nutanix, or Sheldon at Palo Alto Networks, or OneBot at Broadcom, these cute, fuzzy avatars, hundreds of these are resolving millions of employee support requests all over the world, powered by fine-tuned large language models. Thank you for your time.